All right, so section 12.4, add subtract polynomials. All right, so when you did 12.3, when you looked at the videos on 12.3, you were told that a polynomial is a finite set of terms. It's a finite set of terms, and it has this form. So each of the terms has this form. It's some real number times x to the n power, where that exponent is a whole number. All right, so that's what these polynomials look like. So it's a finite set of terms. Finite meaning you can count. You can count them. It's a finite set of terms, and each of those exponents is a whole number. So remember your whole numbers. What's the smallest whole number? 0. So 0, and then you start counting your fingers. 1, 2, 3, 4, 5, and so on. So is 2.7 a whole number? No. 2.7 is not a whole number. You don't have, well, I have to be careful how I say this. You don't have 0.7 of a finger. So you count 1, 2, 3, 4, and so on, right? All right. So those are your whole numbers. So 0 is the smallest. So when you look at this idea here, suppose we had, from a previous course, suppose I had 2 plus 3 plus, and then 7 plus 6. All right, so it's going to add those real numbers. All right, so what would you do? Okay, so you probably going to be, all of you are thinking the order of operations. And these are all real numbers, right? So I can combine these constants. So you said 2 plus 3 is 5, and then 7 plus 6 is 13, and then you said 5 plus 13 is 18. All right. So yes, you could do that here, but you could also do this. I'm adding a set of real numbers. So isn't that the same thing as just saying this right here? Isn't that the same thing as just saying 2 plus 3 plus 7 plus 6 without the parentheses? I get the same thing, right? 2 plus 3 is 5. 5 plus 7 is 12. 12 plus 6 is 18. All right, so we're going to use this idea when we add polynomials. All right, so we're about to add polynomials, and then after a while we're going to subtract them. Adding them is the easy one, so we're going to add polynomials. All right, so let's look at this one. All right, so it's going to be number on page 918. Number, let's just start with an easy one. So number 2. So you have negative y minus 2 plus 3y plus 5. So you have these parentheses there. So basically they're indicating that you're adding how many polynomials together?
4.
No, not 4. 2 polynomials. You're adding 2 polynomials. So in this parentheses I have a polynomial. And in this parentheses, I have a polynomial. Now, when you said 4, you meant 4 terms altogether. But this is a polynomial, and this is a polynomial. So usually what happens is, if you're talking about different polynomials, they'll enclose it in parentheses. So I'm adding this polynomial and this polynomial together, correct? Mm-hmm. Okay. Now, make sure you understand that this is a polynomial, because remember, a polynomial is a finite set of terms, and you have a bunch of terms here. And each term is some number times x to a whole number. So if you look at that first term, negative y, is that of this form?
Yes.
Why not? Yes, it does. That's in that video. If there's no exponent there, what's it understood to be? A 1. Does what's a in this case? Negative 1. So if you don't see that coefficient, so in that video you're supposed to look at, and you probably didn't look at it yet, but hopefully you will before Tuesday. You get that negative 1 here, so that's coefficient. So it is of that form. Then we looked at this. So negative 2. Is negative 2 of that form? Those of you that saw that video, is negative 2 of that form?
Yes.
Yes. because you can think of this as negative 2 times x to what power? 0. Good. X to the 0 power, because remember, x to the 0 power, which was on your previous test, x to the 0 power is what number? 1. 1 times negative 2 is still negative 2. Okay? All right, so those are polynomials. Each term is of this form, a times some variable raised to a whole number. All right, and just like we did here, what we did here was we just combined like terms, correct? And all those terms are alike because they're all constants. They're all whole numbers, so I can combine whole numbers. So the same idea is here. I want to combine like terms. All right, so first of all, remember how we did this right here, where I kind of took away the parentheses. All right, because I was just adding these 4 numbers together. I can do the same thing here. I can say something like this. I can say, well, that's going to be the same thing as negative y subtract 2 and then plus what? 3y plus 5. Okay? And now that kind of looks like section 12.3 that you have to review. That's what that looks like. And so in section 12.3, you had to combine like terms. So remember, like terms are terms that have the same variables raised to the same power. And then your constants are like terms. Now remember, constants are the terms that don't have a variable attached to it. So in this particular case, which ones are your constants? Negative 2 and 5. Very good. All right, so I have this term here, negative y. Can I combine it with something else? 3y. Because those two terms have y raised to the same power. What's that power? 1. So remember in section 12.3, when you look at the videos, basically what you're doing is you're adding the coefficients. What's this coefficient that I'm pointing to right here, that first term? Negative 1. And you're going to add that to that other coefficient. What's this coefficient here? And if you don't remember your sign numbers, use your calculator. What's negative 1 plus 3? Okay, so that means this. That means that negative y and 3y is going to give me what? 2y. Very good. And then remember, if there's only one variable, we tend to write in descending order. So that means that the constant is always written last. Okay. So let's talk about the constants now. What's a negative 2 and a positive 5? Don't say 3, say what? Positive 3. So this is your answer, 2y plus 3. All right, so that's number 2. And that's what the adding polynomials is about. So to add polynomials, you just combine like terms. That's all you're doing. Combine like terms. And the combining like terms goes back to section 12.3 that I asked you to look at. All right, so number 4. Let's do number 4. All right, number 4, you have something that looks like this. All right, so you have this. Now remember, what does the parentheses indicate about this expression that you're looking at? That these are 2 polynomials, and so you're adding these 2 polynomials. And so if I'm adding 2 polynomials, then basically I can just combine like terms, right? So I'm going to rewrite this to make it look like section 12.3. Now you don't have to. You can just go ahead and tell me what the answer is. But if you need to make it look like the previous section, then this is what you would say. You would say, all right, well, this polynomial, I can just rewrite it without the parentheses. And this polynomial, I can rewrite it without the parentheses. All right, so that would be section 12.3. And then now just combine like terms. And before we combine like terms, let's just write in descending order, because this is one of the things you have to do in the previous section. On one of those worksheets, you have to put something in descending order. So you go from, descending order means you go from largest exponent to smallest. Okay, so which term has the largest exponent? 4x squared. All right, so I'm going to underline it. Now you don't have to underline it, but I'm just going to do that. Can I combine 4x squared with anything else? No. So I'm going to list it first. So that takes care of 4x squared. Then the next, so I'm going from x squared, so the next exponent is going to be x to what power? The first though, right? Okay, so that means that this term here, can I combine it with anything else? This negative 3x. And so those two are alike, correct? So just remember, when you combine like terms, you're basically going to look at their coefficient, you're going to add their coefficients together. So this coefficient is what? 3. This coefficient is, what's 3 and a negative 3? Okay, so that means that 0x is just what? No. 0 times x is 0. All right, so I just leave that off. I don't worry about that term anymore because that's just 0. So leave it off. All right, and then the only thing left are the what? Constants. So what's 8 and 3? 11. So what's the answer? 4x squared plus 11. That's the answer. All right. Number 8. All right, number 8, you have something that looks like this. So again, I'm adding two what? Polynomials. So to add 2 polynomials or to add 3 polynomials, whatever many you have, you're just combining like terms. So basically, and this, you remember how in 2 and 4 I rewrote without the parentheses? You can do this, but probably what some of you are going to say is, well, the largest exponent is what? Well, the largest exponent is 2, so that's going to be this term. Can I combine it with anything else? Yes. So this coefficient is what? But this coefficient is 7. I'm adding it to a negative 3, and I get 4. So that means 7x squared and a negative 3x squared is going to be a what? 4x squared. So we're putting in descending order. Then the next one is going to be the x to the first. So that's this right here. Can I combine it with anything else? Nope. So I'm going to rewrite it. And then the last thing is your what? Constants, your constant terms. So a negative 9 and a positive 5 is a negative 4. So there's your answer. And this is in descending order. You're going from largest exponent to smallest. All right, so that's number 8. Okay, number 10. Number 10 you're going to need your calculator with because those are decimals. So let's look at 10. So in 10, you have 9.6 y cubed plus 2.7 y squared minus 8.6 plus, and then you're adding this polynomial, 1.1 y cubed plus y cubed minus 8.8y, and then 11.6 plus 11.6. All right, so I want to put in descending order. So what's the largest exponent? Yeah, but the exponent, the largest exponent is what? 3. All right, so how many terms has that in it? 2. So I'm going to line them. So that's 9.6 and 1.1. And you could actually do that in your head. What's 9.6 plus 1.1? 10.7. All right, so that's going to be 10.7 y cubed. Okay, so don't forget the variable. So the next one will be the squares. Now, there are different signs, so use your calculator with that. So in your calculator, what's this coefficient right here? 2.7. I'm going to add it to a... Oh, you're right. I'm sorry. Yeah, you're right. Nothing. Thank you. So that's just 2.7y squared, correct?
Correct.
All right. Then the next one's going to be what exponent? 1. How many terms have that variable in it? Just 1. So what's going to be the next one?
Negative 8.8y.
Yep. All right. So that takes care of this one. And then the only thing left are your constants. On your calculator, what's a negative 8.6 plus 11.6? It's just 3. So it'll be plus 3?
Yeah.
So that's your answer. Now, none of these are alike, right? Because this, even though they have the same variables, what the exponents are what? Different. So they're not like terms. They're different terms. They're unlike terms. Okay, but 12 it has fractions in it. You have your calculator. So negative 4/7 n squared plus 5/6 m minus 1/20th, and you're adding 3/7 n squared minus 5/12 n. Those are all n's. Oh, I'm sorry. Okay, hold on. There's yeah, there's an n and an m in it. I'm sorry. So this right here is an m, but that is an m. N, m. This is an m as well. So n, m, and minus 3/10. Okay. Now in this case you have different variables in there. So all the other problems you had the same variable, either y or x or p, whatever it may be. But here you have an m and an n. But let's just still put the largest exponent first. So I have an n squared, correct?
Yeah.
Is there any other terms that has that n squared in it? Yeah. Now on your calculator, if you need to, just say negative 4. Now I mean, you could have done this in your head, because notice this is negative 4/7 plus 3/7, correct? So I'm adding two fractions, so the denominator is already the same. So I just add their numerators together. What's a negative 4 plus 3? So this is just negative 1/7. All right. So if you didn't know that, then use your calculator. You would say negative 4/7, negative 4 divided by 7, plus, so negative 4/7. Just trying to make it, okay, so negative 4/7 plus 3/7 plus 3 divided by 7. Press equals, you get this decimal, and then you change it back to a fraction. So second PRB equal, and you get negative 1/7. Okay? So the negative 4/7 plus 3/7 is negative 1/7, but that means that negative 4/7 n squared and a positive 3/7 n squared is going to give me what? N squared. All right. Then let's do the m's. So this is 5/6 right here. What was that? Yeah, and then you're adding it to a what? Negative 5/12. All right. So use your calculator. Now on a test, you want to use your calculator here because you don't have time to do this by hand. You're wasting probably 2 minutes or so for some of you. So 5/6, 5 divided by 6, plus a negative, negative 5 divided by 12 equal this decimal. So I change it back to a fraction, and I get 5/12. Okay? So that means that 5/6 m and a negative 5/12 m is what? Positive 5/12 m. Okay? Now, just to remind you, and it's important you do know this, even though you have access to a calculator, when I add these two fractions with unlike denominators, you got to find your LCD. Now you can use any common denominator like 24. If you want to use 24 as a denominator, you can. If you want to use 48, you can, but it makes the numbers bigger, and you'd have to reduce at the end. But we tend to use the least one. So what's the smallest number that 6 and 12 go into? 12. So you can write two equivalent fractions with 12 as a denominator. So remember the word equivalent fraction. So 5/6 is equivalent to what number divided by 12? That's what you got to find out. So you said 6, right? You said 6 times 2, and what you do to the denominator, you do to the numerator. So 5 times 2 is 10. So 5/6 is equivalent to 10/12. Negative 5/12 is equivalent to what? Negative 5/12, because you could say 12 times 1 is 12, and then negative 5 times 1 is negative 5. So now I can combine them. What's 10 and a negative 5? 5, so I get 5 what? twelfths, which is what we had. Okay, and then use your calculator with this one. So a negative 1/20th and a negative 3/10. So negative 7/20ths. Okay, make sure you, I'm just writing what someone told me, so the rest of you, if you have a calculator, make sure you do it. Negative 4/5, all right, let's do it. Negative 1/20th, negative 1 divided by 20, plus a negative 3 divided by 10 equal, and then second PRB is equal negative 7 over 20. So you got to figure out what you did in your calculator, okay? All right, and then there's your answer. Okay, so any questions on adding these? Okay, so adding the polynomials are easy. All right, let's talk about subtracting them. All right, so to subtract them, let's kind of talk about this. Subtracting is easy also. All right, so we're going to talk about subtracting. Before we do that, let's look at this idea. So if I have 7 plus 3 subtract 2 plus 4. 7 plus 3 subtract 2 plus 4. Use the order of operations to begin with. What's 7 plus 3? 10. So that's 10. Subtract, and then 2 plus 4 is 6. And 10 subtract 6 is 4. Okay, so no big deal. But remember, what if you had this? What if I had 8 subtract 10? Is it 2? No, it's negative 2. Now, one of the things you need to remember from a previous course is that you can always, and we did talk about this in here, you can always change subtraction. What kind of problem? Addition. So you got to remember, you got to add, the phrase is add the opposite. So when I read this as a positive 8 subtract a positive 10. A positive 8 subtract a positive 10, because in a previous course you had something like this as well. So when you read this as a negative 8 subtract a what? Positive 10. Then you had something like this. When you read this as what in the previous course? A negative 8 subtract a negative 10. So remember all the different ways to say these things. And so when you did things like these, though, in a previous course, you changed this to an addition problem. So so remember, you add the opposite. So you'd say negative 8 plus the opposite of a positive 10, which is a what? Negative 10. And so what's a negative 8 and negative 10? Negative 18. Here you said, all right, I'm subtracting, so I'm going to change it to an addition problem. Now that's going to be important with what we're about to do. So it'll be negative 8 plus the opposite of a negative 10. What's the opposite of a negative 10? Positive 10. And what's negative 8 plus 10? 2. Here you would say 8, a positive 8 plus the opposite of a positive 10, which is a what? And so what's 8 plus a negative 10? Negative 2. Okay? All right. So what I'm trying to get here is this. Do y'all agree? Now remember, if this was addition, when we did the addition here, I just removed the parentheses. Okay? All right. So but this is not you're not adding two sets of numbers. You're doing what? Subtracting. Okay. So you're going to use this idea that we just talked about, adding the opposite. But do y'all agree that this is the same thing as this? I want you to make sure you understand this. This is the same thing as saying 7 plus 3. Because remember, when we changed this to addition, we kept the first number the same. We took the opposite of the second number, right? All right. So that's what this is right here. So I'm going to say, all right, so that's going to be a change to subtraction to addition. But that means I got to take the opposite of each of these numbers. What's the opposite of a positive 2? And what's the opposite of a positive 4? Negative 4. So now let's combine like terms again. So this is 10 plus a what? Negative 6. And what's 10 plus a negative 6? Positive 4. All right. So this is the idea that we're going to use in a little while. All right. So watch what happens. So this is going to be number 18. So now we're subtracting polynomials. All right, we're subtracting polynomials now. So this is what it looks like. So you have this first polynomial, 4 plus 5a, subtract this second polynomial, negative a minus 5. So notice, am I adding or subtracting those two polynomials? I'm subtracting. All right, so you're subtracting those two polynomials. That's 4 plus 5a, yes. And you're subtracting a negative a minus 5. Okay, so let's talk about what we just did here. So this is subtraction. I want to change this to what kind of problem? Addition. So what this becomes is 4 plus 5a plus, and then all I do with each of those terms that's in the polynomial following the subtraction symbol, what do I do to each of those terms? Take the opposite. So negative a becomes a positive a negative 5 becomes a positive 5. All right, make sure you understand that. So you add the opposite. Add the opposite. The opposite of a negative a is positive a. The opposite of a negative 5 is a positive 5. Okay? And now that kind of looks like all the other problems we had a while ago. So now I can combine like terms. Put in descending order, there's only one set of variables. What's 5a and what can I combine it with? A. What's 5a and a? 6a. What's the, and then when I combine the constant terms, and that's a 5 here, what's 4 and 5? 9. So there's your answer, 6a plus 9. All right, so when subtracting polynomials, basically what we did was we changed the signs, of the terms that's in which polynomial? The second polynomial, the one that follows the subtraction symbol, and then we did what to those two polynomials? We added them. Okay? So basically what we did was, now don't memorize this, all you got to do is just remember from previous course what we did here, and it just follows from a previous course. But when you're subtracting polynomials, you got to change the signs of each term of the polynomial following the subtraction symbol. And then add the polynomials. All right, so it's not difficult. Just one little thing you got to do, and then it looks like the previous problems we did. So you're going from subtraction to what? Addition. So you're going from subtracting two polynomials to adding two polynomials. So we look at number 20. Very simple, not difficult. Here are my two polynomials. Negative 7y squared plus 5. I'm subtracting this one. Negative 8y squared plus 12. All right. So the best way to do this is to right away just change this to an addition problem and keep the parentheses. Actually write in that step. So this is going to be negative 7y squared plus 5 in parentheses. Now this subtraction becomes what? Addition. So remember the phrase, add the opposite. So the terms that's inside this parentheses, take the opposite. So what's the opposite of a negative 8y squared? 8y squared. What's the opposite of a positive 12?
Negative 12.
And now you add them. It's been descending order. So which terms are alike? If I'm going to put in descending order, which terms do I look at first? Negative 7y squared and a what? 8y squared. And so you're adding the coefficients, and if you can't do that in your head, use your calculator. So a negative 7 and a positive 8 is a positive 1. Okay. Now, so that means that negative 7y squared plus 8y squared is just what? Y squared. Now, don't say 1y squared, because 1y squared is just what? Y squared. So just write as y squared. Y squared is understood to have what coefficient? 1. And the only thing left seems to be what? But what are those called? The constants. So this constant's a positive 5. This constant is a what? Negative 12. What's 5 and a negative 12? Negative 7. So your answer is y squared minus 7. See, very simple. It's not difficult. All right. Let's do 26. Okay, so here's 26. All right, 26, you have negative 6y squared plus 3y, so those are y's, minus 4, and you're subtracting 9y squared minus 3y. All right, so what do you want to do first? Rewrite an addition problem. So the first polynomial stays as it is. So I'm just going to write that first polynomial, and then I'm going to change the subtraction to addition. But when I do that, that second polynomial, what do the terms become? The opposite. What are they, though? Negative 9y squared plus 3y. And now I just combine them. So if I combine like terms and put them in descending order because they all have the same variable, which terms do I combine first? Negative 6y squared can be combined with what? Negative 9y squared. So what's a negative 6 and a what?
Negative 9.
Negative 9. What's a negative 6 and a negative 9? Negative 15. Okay, so negative 6y squared and negative 9y squared becomes a negative 15y squared. Then what other terms would I combine next? 3y and 3y. What's 3y and 3y? No, not 9. 6, right? It's all right. Plus 6y. And then the only thing left is the what? Negative 4. And that's it. That's your answer. Okay? And then you have decimals again, and you have fractions again. So let's just quickly do one of the decimals. So this will be 28. So 28. You have negative 0.3y squared plus 0.6y minus 0.3, subtract, and then 0.5y squared plus 0.3. All right. Okay, so what's the first thing you're going to do? Rewrite an addition problem. So you get negative 0.3y squared plus 0.6y, subtract 0.3, and then you're going to add the opposite. So when I add the opposite, what does that second polynomial become? Negative what? And then 0.3. And then the rest, and then you just add your like terms, combine your like terms. So if I put in descending order, what two terms would I combine first?
Negative 0.3y squared
And
0.5y
negative 0.5, right?
Mm-hmm.
Okay, so on your calculator, what's a negative 0.3 plus a negative 0.5?
0.8y squared.
Negative or positive?
Negative.
Negative. Okay, so the answer is going to be negative 0.8y squared.
Mm-hmm.
Okay, now the next one I would have to well, there's only one, right? So I'd have to say what?
0.6y.
Plus 0.6y, because there's nothing else I can combine it with. And the only thing left are your, what are they called? Your constants. So it's a negative 0.3 and a negative 0.3.
Negative 0.6.
Negative 0.6. And so there's your answer. All right. And then finally, the one with a fraction in it. So this will be number 30. Use your calculator with those. So you have 1/3 x squared minus 2/7 x, subtract 421 x squared plus 1/21, that's 21, x minus 2/3. All right. Am I adding or subtracting those two polynomials? Subtracting. What must I write it as? Addition. So that's where you're going to add the opposite. So the first polynomial stays the same. Then I'm going to add the opposite. So 421 x squared becomes a negative. A positive 121x becomes a negative. And a negative 2/3 becomes a positive. All right, and then the rest is just using your calculator to combine like terms. So if I put this in descending order, which two terms must I combine first? 1/3 x squared and a negative 4/21 x squared. So add their coefficients. So on your calculator, what's 1/3 plus a negative 4/21? Huh? 1/7. Is that what y'all got?
No.
So let's see. You're saying 1/3, 1 divided by 3, plus a negative 4 divided by 21 equal, and then change it back to a fraction, 1/7. So it's 1/7. So it's 1/7 what? X squared. Okay. Now, what so what did you say? You said what?
To 28 over 21.
Yeah, so she didn't have a calculator, so she's trying to do it by hand. So if you do it by hand, you gotta remember our rules. So you're saying 1/3 plus a negative 4/21. What's the LCD?
21.
21. So you're writing two fractions with that denominator. So 1/3 is equivalent to what number divided by 21? So, well, 3 times what's 21?
7.
1 times 7 is 7. These are already 21, so this has to stay what? What's 7 plus a negative 4? It's 3/21, which reduced is what? 1/7. Okay? And what did you say earlier?
I said it backwards. I had did something wrong.
Okay. All right. But anyway, so just make sure you don't leave it as 3/21. It's got to be reduced. Okay? All right. Now, using your calculator, negative 2/7 x and a negative 1/21 x is what? Negative 1/3. Okay. And then the only thing left is what? 2/3. There's your answer. All right, so that's all you do there. Okay. And on my math lab, we're basically done with this. Oh no, we're not. Sorry. Okay. But the reason I'm saying we're not done with this because on my math lab, they use the word subtract as well. So there are some problems in there. If you have your book in front of you, it's like 47 through 56 where they have the word subtract from. Remember earlier in the course, you had something like this, subtract 6 from, let's say, 2. All right, so if you see something like that, what does that mean you write it as? 2 minus 6, good. Not 6 minus 2. You're subtracting 6 from what? 2. So it's 2 minus 6, which gives me what? Negative 4. So what we're going to do, because I want to go into graphing linear equations for the remainder of the period. So we're going to do the rest of this next class period, but basically it's going to look like this. I'll say subtract something like, let's say, 3x from 6x minus 2. That's what we're going to look at. All right, so it's going to be the same way. So do I put 3x first or do I put that other polynomial first? The other polynomial first. So basically this is going to become 6x minus 2 and then subtract what? And then you combine like terms. What would be the answer? Yeah, because 6x minus 3x is 3x, and so it's 3x minus 2. So that's what we're going to talk about next time. Okay? All right, so that's going to take care of this part.